Today we're going to look at Chapter 2 and some of the various definitions that come out of Chapter 2. Most of Chapter 2 is going to be working with data and organizing it into different types of charts and tables. The one that we're going to look at more often than any other is the frequency distribution. And what a frequency distribution is we take our data and we organize it basically into a table. This table has classes. An example of that is on page 53, Table 2-2. And that deals with pulse rates of women. Now notice we have pulse rate, and we have a range, and we also have a frequency on this side. And those are our classes. Now there are some definitions that go along with our frequency distribution. And these definitions are at the bottom of page 53. And let me read them to you. We have a lower class limit, and that's the smallest number that can belong to the different classes. And we have an upper class limit, which is the largest number that can fall in various classes. We have class boundaries, and they're a gap between the two classes. We'll talk about that in a moment. We have class midpoints, which are found by adding the upper and the lower limit together, dividing by 2. We also have class widths. Now the class width is usually provided for you. The class width is determined by a statistician or someone who knows the data. Changing the class width can dramatically change how the data is presented. Now let's go back and look at our table 2-2. Now when we look at this, we have our pulse rates. And notice we have 60 to 69, 70 to 79, 80 to 89. The 60, 70, and 80, those are your lower class limits. The 69, 79, and 89 are your upper class limits. Now the boundaries come about as the area between the two classes. For example, if we record the pulse rate at 69.75, where would we put that? Obviously we'd round it up to 70 because it's more than 69.5, so we round up. So the borders are actually a 0.5 on each side. So if we were to include our borders, we would have 59.5 to 69.5, 69.5 to 79.5, 79.5 to 89.5, and so on. Now we don't usually put the borders on there because it makes the graph look too complicated. So we don't put those on there because it kind of makes it look dirty. We want a clean, nice, concise graph, so we don't put those borders on there. But they're actually there. Now from the frequency distribution, we can create what are called relative frequency distributions. And relative always means percent. So whenever you see the word relative, you know you're going to have percentages. Example of that would be Table 2-3 on page 55. Notice it has percentages there. We can also look at cumulative frequency distributions. And cumulative just means we add them up. And this is on Table 2-4 on page 55 again. And very important about cumulative, though, is you see they are all less than. So it's less than 70, less than 80, less than 90. And they just add up as you go along. Now we can also use these frequency distributions to create histograms. And histograms are like bar charts, but we use the word histogram, not bar chart. Now on a histogram, we have to include our class borders. So those are the halves, the 0.5 and the half on the side of each class limit. An example of this is on page 63. Notice how it starts at 59.5, 69.5, and so on. And that's figure 2-3. We can also make a relative frequency histogram. And that just means your vertical axis is going to be percentages instead of frequencies. We can also make frequency polygons. Now frequency polygons are kind of like line graphs. And they work with your frequencies. But the thing about frequency polygons is they use class midpoints. And you find your class midpoint and you plot your corresponding frequency and then you connect them together. They can also be relative. Examples are on page 70, figure 2-5. And a relative one is figure 2-6. Notice their line charts there. Another one that we can make with a frequency distribution is an ogive. And an ogive is cumulative, so we use our cumulative frequencies. Now notice we do not use our class midpoint, we use our class borders. We can also create a variety of different charts. We can make scatter charts, stem and leaf plots. We can also make Pareto charts, which Pareto charts are like histograms, except that we use categories instead of classes. Pie charts, time series charts, all kinds of different charts. Most of those are pretty self-explanatory, so that should conclude our definitions for Chapter 2.